Now I would like to introduce Daniela. Daniela is completing a PhD in epidemiology and public health at the Swiss Tropical and Public Health Institute, and her work focuses on malaria surveillance in Papua New Guinea. She will be presenting on behalf of the Papua New Guinea Institute of Medical Research the preliminary result of an integrated and TDR-funded study that attempts to understand the drivers of local, residual and persisting malaria. So Daniela, please, thank you.
Good morning, everyone. Thanks for coming. It's the last day and it's early, so it's very appreciated. I'm happy to present some of the preliminary results on behalf of the Papua New Guinea Institute of Medical Research on this project that tried to understand the interactions between human parasite vectors and the environment that are currently driving residual transmission in Papua New Guinea. So first of all, Papua New Guinea, it's a country with a high malarial burden. It's the highest outside of sub-Saharan Africa, and it's estimated that 90% of the people, or the population, is at risk. There are 4 different species of Plasmodium present in the country. There are multiple Anopheles vectors, and it's an environment with complex control. Historically, malaria control in Papua New Guinea started around the 1960s with the Global Eradication Program, and it continues on the 70s with indoor residual spraying and mass administration of chloroquine, but it ended on the 1980s. There was a complete close of the program, and there was observed resurgence of malaria, and there was a shift on the dominant species from P. vivax to P. falciparum. Then new efforts started in 2004 with the support of the Global Fund, and the 2 core interventions were the free distribution of the long-lasting insecticidal nets and the introduction of artemisinin-based combination therapy as the first-line treatment in the public health facilities. And currently, the regional goal for elimination is set for 2030. So the rationale for this study was, first off, after the scale-up of the National Malaria Control Program, we observed that malaria was reduced, but it was not the same effect everywhere, and also there were resurgences that got observed. And currently there's minimal data that exists on drivers of residual malaria in transmission settings with multiple Plasmodium and Anopheles species. And finally, we want to better understand the extent of local heterogeneity to better identify and implement targeted control strategies. So the approach of our study wanted to look at 3 main components simultaneously. So we wanted to investigate the human infection, the human behavior, and the transmission. And then to observe human infection, we had health facility surveillance to measure incidence, and we had some prevalence surveys. And then for the human behavior, we had a mixed method approach with quantitative and qualitative data collection. And then for transmission, we have an extended entomological survey that used human landing catch, barrier screen, and also targeted mosquito collections. So for this study, we selected 2 sites in Papua New Guinea, one in the north coast, one in the north coast of Papua New Guinea, Mugil Health Center, and the other one is in the island regions in Lamakot Health Center. We chose these 2 sites because they both have a very interesting and unique malaria epidemiology. And during the surveillance time in the health facilities, we found some interesting characteristics of these sites. So we selected 4 villages in each site. In Lamakot, we have 2 villages in the east coast and 2 villages in the west coast. And in Mugil Health Center, we have 2 coastal villages and then 2 inland villages. So now I'm going to show you some preliminary results Well, the first result is the prevalence, so we wanted to assess it with light microscopy and PCR. The PCR sampling processing is ongoing, but these are the prevalence that we found. So the lowest was 1% in Lemmakot, and then the highest was 19% in Mukel Health Center catchment area. But I just wanted to point out that PCR is detecting, we have a difference between the submicroscopy detected infections and the light microscopy. So there is a significant difference, and then this processing is ongoing for the rest of the samples. And now I'm going to use one of the village to kind of illustrate and try to summarize some of the main results that we have. So I will focus on one site, but this exercise was repeated in all sites. So first of all, for the human infection component, we wanted to look at the prevalence, and we wanted to answer this main question. So who is infected and where do they live? So we did a prevalence survey and we linked it to GPS location. And here we have a map that shows the location of each house. And in black we see the households with no malaria infections, and in red we see the household with at least one positive malaria infection. And then this could lead us to identify potential spatial clusters in the communities. Then for the human behavior component, we really wanted to answer the question, where are people and what do they do during the potential biting times of the Anopheles? And we conducted this behavioral study with IDIs, like in-depth interviews and focus group discussions, and we tried to identify human patterns that could enhance human vector contact and also link these activities to a specific place and a time. So here we see an example of the maps that we were used. We would sketch a map of the village and then have this discussion with a group of men or women and ask them what do people usually do and where do they are at the times that mosquitoes, Anopheles, are biting. And then lastly, to understand transmission, we here see the exposure to anophelines. So in this map, we have all the households that we identified in the village, and then the red dots are the households where we conducted mosquito collections. And here we can see like a heterogeneity in the exposure to anopheles. They are really located regions or areas in the villages that we can consider hot spots with way higher exposure to mosquito bites. And then with this data, we really want to answer the question, do mosquito bite at places of residence of outdoor activities? So this example was from Mukel Health Center. This is a short example of Lemmakot. So for instance, in the health facility surveillance, we find that in the year of highest transmission, 2012, we find way more female infected in the health facility. So the behavioral study showed that one very common activity taking place at dawn is bathing, and in Lemmakot there are designated areas for bathing, and they are different between male and female. So then we went to these designated areas and did mosquito collections, and we find quite a difference in the number of Anopheles varieties at this specific site. So we couldn't find any in the male area, but then we find quite some vectors in the female area. So as I said before, the study is ongoing. We still have quite some sampling to do. So we are at the moment processing samples to know better and to better understand the Plasmodium composition and also the vector composition and the behavior of the vector, and then the relationship between Plasmodium diversity and the vectors, and finally this relationship with the vector and the human contact patterns. So once all these analysis is done and these samples are processed, we'll piece it all together and then we can really answer the main question. So can human behavior and mosquito ecology explain the residual transmission in our study sites, and how is it happening? So I want to deeply thank our field team. They are a group of amazing people that have been doing really hard work, collecting the mosquitoes at the health facilities, doing the prevalence surveys, and we have a fantastic microscopy team. So I really want to thank all of them. And I also want to thank everyone that has been part of this huge project. And all the participants are the villages and the village leaders as well. They were very welcoming and they make it all possible. Thank you.